Hello everyone. So now I will solve stick lengths of CSES problem set. So let's jump to the problem statement. So there are n stick with some length. Okay. Your task is to modify the stick so that each stick has the same length. Cool. Like okay, you can either lengthen or and shorten each stick. Okay. Both operation cost x where x is the difference between new and original length. Okay, so we have to find what is the minimum total cost. Okay, so let me take this example. Okay, let me erase this. This is our array like length of each stick. Okay, what we have to do? We have to make we have to make sticks of same length. Like we have to make it equal. And how we can make it equal? We can either shorten it or elongate it, and we have like there is a cost to it for these operations. And what is the cost? The difference between new and original length. Okay, so suppose this is my length. So suppose let's take any random number p. Okay, so this is the length I want to convert each stick to p. Okay, it is the length I want to convert each stick. Okay, so what will be the cost of each? What will the total cost? I would say mod of 2 minus p plus mod of 3 minus p plus mod of 1 minus p plus mod of 5 minus p plus mod of 2 minus p. Okay, so we have to minimize this. And how I can, so we have to choose p such that the sum of this is minimum. Okay, to minimize this. Okay, so how do we go? Okay, so I would say like let me tell you two statements. Okay, so like you have to keep in mind every time. Okay, if you want to minimize sum of absolute differences, absolute differences, so we have to use median. I will prove it to you. Okay, and if we want to minimize sum of square differences, so what you can use? Mean. Okay, so how am I saying this? Okay, so let's have a proof to this. So how can we prove this? So what is this is sum of the. So can I write like this way? Like this is sum of. I can't write sigma here because I don't have like keyboard button. So I am writing S. Okay. So A of I minus P. Okay. So we have to minimize this. or you can say x instead of p. So how can we minimize it? And there is mod also. Okay, to minimize it, we have to first find the derivative of it. To minimize, find derivative. Okay, and what is the derivative of any mod function? Suppose, what is the derivative of mod x? The derivative of mod x is signum function, signum of x. How can you say that? You can directly imagine also. Like you can you imagine the mod x function? It's like V shape. Okay, it's like V shape, no, like this way. So for this, its slope would be -1, and for this, its slope would be 1. So that is signum function. Okay, so what would be the derivative of a of I minus x? Signum of a. So I would write dy by dx equals sum of signum of a of I minus x. Okay, and what is signum function? Like it's -1 and +1, nothing else. Okay, so this is the thing. Now we have to apply some common sense, okay, and common logic to like decode what to do now. So what we can do is like this is a of I minus x and signum. So suppose there are in sigma there are suppose five elements. Okay, five elements. So sum of five elements is there. Okay, so to minimize it, I want it to be zero. Okay, to min for minimization. Okay, so we want our sum to be this dy by dx to be zero. Okay, so what can we do here? Like so signum function would be 1 if it is positive. Signum of signum would be equals to 1 if a of I minus x is greater than 0. Okay, and signum function will be equals to -1 if a of I minus x is less than 0. Okay, so it's simple now. Can you get this? That signum of how I have done this to this. It's a normal signum function. And so I want this to be 0. Okay. So I want equal numbers of +1 and equal numbers of -1. Okay. So, and what is signum of 0? Signum of 0 is 0. Okay. So if there are 5 elements, so I want 2 +1 and 2 -1. 2 -1. And 1 would be 0. And 1 0. Okay. So how can we get this? So I want a number which is in the middle of middle of the array, which is the middle of the array, so that half of the numbers are smaller than that number and half of the numbers are greater than that number. Okay, for suppose we, we need sorted also to see half. Okay, 1 2 2 3 5. Okay, so here I want this middle one. Okay, so this would be 0. Okay, and what would be this? This will also be 0, and this would be -1, this would be +1, and this would be +1. Here we can't have 0. Okay, so this example is a bit tricky one, so let me explain you with some other example, then I will come to this. Okay, so suppose 1 2 3 4 5 we have. Okay, so what I have to do, I have to find a number like signum function should be a of I minus x should be like I want two like 1 0 and two positives and two negatives. So the answer would be here 3. Okay, so that's a median, because like for 1 2 it would be negative, and for 4 5 it would be positive, and for this it would be 0. So overall answer would be 0, so the derivative is 0, hence minimum. Okay, so now let's come to this example. This example is like the median is 4. Okay, sorry, 2. So if we come here into, so positives will be 2, zeros would be 2, and negatives would be 1, so overall it would be positive 1. So there is a problem like w- we want our derivative to be 0 for minimization. Okay, so why it's positive 1? So the main my answer is that suppose you are here at 2 right now, we have one extra positive, like two positive ones and one negative ones. There is imbalance. But if we increase, like if we ever increase our median like by 2.1 to, if we increase our median to 2.1, so what would be there? Left will be like 3, and so negatives will be 3 and positives will be 2. Okay, and if let me write here, if we have 2 as median, so what is the thing? 2 positives and 1 negative. Okay, if we have 2.1, so what does that mean? We have 2 positives again, 2 positives and 3 negatives. Okay, this making overall +1, this making overall -2. Okay, and what if I have 2 1.9? Okay, it's not like it's like tending to 0, but a little less than, like you have studied in limits like that. Okay, so if we have taken our median as 1.9, what would be there? Like we will have 1.9. Okay, so we will have one negative and four positives. Four positives. So making that plus 3. Okay, so we can see that here the value is changing from positive to negative. So there, so that's the balance. Like it's if it is changing from positive to negative, so we have to assume that there would be zero. That's it's a bit tricky one. So we can like if you want to go further, then you can research about that. But yeah, that's it. Like there is a transition from positive to negative at 2, so that's why it is our best answer. Like the derivative should be 0 here at 2. It actually it is not, but it's like interpolation. Like it is going to 0 at 2. That's why we have like the answer would be 2 here, not the answer. Like p would be 2 here. Okay, so let me code it for you. So I have taken the input also, and let me sort it. So what would be sorting? V dot begin, V dot end. Okay, if what should I say? uh, Now I am to find n by 2. Okay, V of n by 2, that would be our median. Okay, and now I want to like do summation of AFI minus median. Okay, sum plus equals. So let me write here long and sum equals 0, and what would be here? V of I minus median. Okay, and that would be our absolute value. So please let me write here. So that's it, and let me print here C out sum. So let me check this. Yeah, yeah, we are getting. So let me try to submit it and check it again. Yeah. Okay. So we have solved it. So what are the things we have learned? This is the main thing. Okay. I have also like derived it. You can also prove it for mean also, like how to minimize the sum of the square differences. Like you can again take the derivation, and you can derive it. Okay. And I have done this for median. So keep in mind these two. Okay. So that's it from my side. Okay, bye.